Good morning, ladies and gentlemen. Today we are going to solve inequalities that contain fractions. This is chapter 14, section 7. Because we're dealing with inequalities, we have to go over the three situations where you would have to flip over an inequality symbol. If you multiply both sides of the inequality by a negative number during the solution of the problem, you have to flip over the inequality. Instead of giving you all the true values, once you multiply by a negative, that inequality gives you all the false values. So we flip it over to get it back to true. Dividing by a negative, this is the one that happens most often. If you divide both sides by a negative, you have to flip over the inequality. And if you decide that you have the variable on the wrong side, you want to get it over to the correct side, you have to flip over the entire problem. So if you choose to switch the sides using the symmetry property of algebra, you will have to flip the inequality as well. This is done in the last step. And sometimes you can do it earlier, but make sure that it's at least, obviously it has to be done by the time you're done with the problem. Alright, so in problem number 1 here, we do not have a proportion, and cross multiplying with inequalities is not something you want to do anyway. So what I'm going to do is I'm going to multiply everything by 6, which is the least common denominator. 3 times 6 is 18. I could use 18, but it's not the smallest denominator that 3 and 6 both go into. So this gives me 6x over 3 minus 6x over 6 is greater than 72. Now I can reduce these fractions, and that's actually why I multiplied by the LCD. It's because now I can actually reduce these and have no fractions at all. 3 goes into 6 2 times. 6 goes into 6 1 time. So I have 2x minus 1x, which is of course just x. X is greater than 72 is the final answer. And look how easy that is. Fractions are the enemy. It makes problems much harder to solve. So our goal is always going to be to get rid of fractions as quickly as possible. Here the least common denominator is 14, so I'm going to multiply everything by 14. So this gives me, let's see, 42y over 2 plus 14 times 8 minus 4y over 7. And that's less than or equal to, let's see, 42. Now notice here in the middle step, which I'll circle in green, I did not actually distribute. Whenever you have a distributive property, you want to stay away from actually doing it, because our goal after multiplying by the least common denominator is to reduce the fractions. If I distribute, I'm just going to have to factor, so I'll be chasing my own tail here. 2 goes into 42, 21 times, so this gives me 21y. Now look what happens. 7 goes into 14 2 times, the fraction is gone, and I still have to distribute, but I don't actually have to multiply a 14 in there, just a 2. The fractions are gone, that was our goal. And then less than or equal to 42 comes down. So now we distribute 21y plus 16 minus 8y is less than or equal to 42. Because we have 3 terms on the left, we must be able to combine some like terms. So how about 21 minus 8, which is what, 13? We'll subtract 16 from both sides. I'll move over here. 13y is less than or equal to, let's see, 22 and 4 is 26. And then divide by 13. Y less than or equal to 2. Alright, so what did we do here? We multiplied both sides of the inequality by the least common denominator, which is 14. 14 times 3y we did here. 14 times the numerator we did there, but we didn't actually distribute because that would have made the problem a little bit trickier. 14 times 3 over here. Now we can reduce the fractions. So we had 2 went into 42 21 times. 7 went into 14 2 times. Here's that 2. We'll distribute it in later. And we did. We distributed in, combine like terms, subtract and divide. Y less than or equal to 2. Alright, number 3. Here the least common denominator is 8, so I'm going to multiply everything by 8. This gives me 8x over 4 minus 8x over 8 is less than or equal to 40 over 8. Keep in mind I'm multiplying by 8 over 1, so I'm only going to multiply 8 times the numerators, not the denominators. 4 goes into 8 2 times. 8 goes into 8 1 time. 8 goes into 45 times. So we have 2x minus 1x is 1x. And there you go. Problem's done. X is less than or equal to 5. There's really not a lot going on here. You just want to get rid of those fractions immediately. Immediately. And they're not going to be proportions. You can't cross multiply an inequality anyway. So we have to kind of get a hold of this technique. Alright, we're going to multiply both sides by 12 here. This gives me 24m over 3 is greater than or equal to, once again, I'm not going to actually multiply 12 into the binomial. 12 times 1 is 12. Alright, so I multiplied 12 times 2m over 3, that's 24m over 3. I multiplied 12 times 7 minus m over 4. I set it up, I didn't actually do the multiplication. That would have been chasing my own tail, because I would have had to factor it later anyway. And then 12 times 1 is 12. Alright, well, 3 goes into 24 8 times, so 8m. 4 goes into 12 3 times, so 3 times 7 minus m plus 12. So I distribute 21 minus 3m plus 12. Because I have 3 terms on the right side, there must be like terms there. 21 and 12 is 33. So when I add 3m to both sides, I get 11m is greater than or equal to 33. M is greater than or equal to 3. Notice we did not have any instances where we had to flip over the inequality. We've done 4 problems now and it hasn't come up yet, so not something that happens all the time. It does happen though. We have to be smart about that. It does happen. Alright, I'm going to scroll up here for number 5. Alright, so 5 times 3 is 15, so we're going to multiply both sides by 15. Because I have binomials, I will not actually multiply. Just setting it up. Just setting it up. I'll scroll over here, give myself some room. 15 times 2 is 30. Alright, so we multiplied everything by the least common denominator. 5 goes into 15 3 times, so we have 3 times 2x minus 3. 3 goes into 15 5 times, so minus 5 times x minus 3, less than or equal to 30. Now we can distribute. We have 6x minus 9. I have to distribute the negative here, so do a leave change if you wish. It's minus 5x plus 15. That's less than or equal to 30. Combine like terms. I have all kinds of junk on the left side. 6x minus 5x is 1x. Negative 9 plus 15 is 6. That cleans up pretty nice. So subtract 6 and x is less than or equal to 24. 5 problems without having to flip over the inequality. Although we did have a distribute the negative here. Distribute the negative. Leave change, as you folks like to call it. Alright, let's see. Number 6. 2, 10, and 5. Well, listen, 2 goes into 10, 10 goes into 10, 5 goes into 10. So how about we multiply everything by 10? This becomes 10 times 6x minus 3 over 2. Remember, when it's a binomial, I'm not actually going to multiply. Here we get 370 over 10. And I get 10 times x plus 2 over 5. Now I can reduce. 2 goes into 10 5 times. So this is 5 times 6x minus 3. Of course, 10 goes into 370 37 times. And 5 goes into 10 2 times. We distribute. 30x minus 15 is greater than 37, plus 2x plus 2 is 2x plus 4. We need to distribute. 2 times the quantity x plus 2. We distribute, and we have a lot of commotion here now. 3 terms on the right side of the equal sign. Let's combine like terms. 37 and 4 is going to be 41. Scroll down and give ourselves a little bit of room. See what we'll do here. We'll subtract 2x from both sides. You get 20. Ooh, almost made a math mistake. 28x minus 15 is greater than 41. I'll add 15 to both sides. 28x is greater than 56. And I'm going to guess that goes in 2 times. 28 times 2 is 56. So x is greater than 2. Gosh, look at that. 6 problems without having to flip over the inequality. It's going to sneak up on us. I have a feeling. I can feel it in my bones. It's coming. Well, we'll see. All right, number 7. Number 7. All right, 10 and 5. Well, the least common denominator is 10, so multiply both sides by 10. We'll show you how you can skip some of this work here. 10t over 10 is greater than or equal to 40 plus 10t over 5. Well, here there's not a lot to do anyway, so skipping it is pretty easy. Here the 10s cancel out, leaving you a t. 40 is going to come down. 5 goes into 10 2 times. So there's really not a lot going on here. Remember our little trick. Because if I subtract t from both sides, I'm going to get 0 on the left. Instead, I'm going to subtract 2t from both sides. That'll give me negative t is greater than or equal to 40. Ah, here we go. I have negative t. So I'm going to divide both sides by negative 1. That means I have to flip over the inequality. So here's our final answer. T is less than or equal to. Flipped it over. Less than or equal to negative 40. There you go. Easy problem, but it had our little flip trick in there. We had to use it. Alright, number 8. 2, 5, and 6. I want to try 15, but 6 doesn't go into 15. I guess I'm looking at 30. It's probably the best choice. So I'm going to multiply everything by 30. So, let's see. That gives me 30 times 2 minus a over 2. Less than or equal to 30 times a plus 2 over 5 minus 30 times 2a plus 3 over 6. Looks like a big mess, but it's going to get awful tidy awful quick. Because 2 goes into 30 15 times. So 5 goes into 36 times, and 6 goes into 35 times. So what we can do here, like I said, want to skip a step, save some work, is go ahead and distribute now. 15 times 2 is 30. 15 times a is a minus 15a. 6 times a, 6a. 6 times 2 is 12. I have to distribute the negatives, so we'll do leave, change, change here. Negative 5 times 2a is negative 10a. And negative 5 times 3 is negative 15. There's a number of steps you can kind of do in your head to save you some work. And there's an example of a step that I've been writing down every problem, but really, once you get the hang of this, you can kind of skip that step pretty consistently. All right, 6a minus 10a is negative 4a. 12 minus 15 is negative 3. Well, I'll add 15a to both sides. That's the smallest variable term. Our rules tell us to move the smallest variable term first. Alright, then we're going to add 3. This thing's finishing up quick. I'll move the over here so I don't have to scroll down. 33 is less than or equal to 11a. We divide by 11. We get 3 is less than or equal to a. Alright, a is on the wrong side of the equal sign, or the inequality I should say. To get it on the left, we have to flip over the inequality. That's that third bullet on the front page of your notes. Whenever you want to flip or get the variable on the correct side of the inequality, you have to flip the whole thing over. Alright, our last problem. The sum of 1/5 of an integer and 1/10 of that integer is less than 40. Find the greatest possible integer. Well, let x equal an integer. That sorts us out with a let statement. 1/5 of an integer. Of is a multiplication word. 1/10 of that integer. And it says sum here, so we're going to add them together, is less than 40. And there's your problem. Pretty easy one. We're going to multiply everything by 10, which is the least common denominator. So you get 10x over 5. You get 10x over 10. And you get 400. Well, 5 goes into 10 two times, so that's 2x. 10 goes into 10 one time, so that's 1x. And that's less than 400. So we add them up, we get 3x is less than 400. And we divide by 3, we get x is less than 400 over 3. Alright folks, I paused here because I kind of felt there must have been some sort of a mistake, but if we read the last sentence, it says find the greatest possible integer. So the fact that 400 divided by 3 is not an integer doesn't actually matter. We have to figure out what 400 divided by 3 is. 133.3 repeating, so we're going to say that x is equal to 133. That is the greatest possible integer that works in this problem. So you can't find the exact answer, you're going to find the answer that's closest to it. So a little bit of a tricky trickster there, but that's how these word problems are. Alright, we'll see you tomorrow. Have a great day. You see the assignment down there. We're going to get started on it in class on Tuesday.